All right, so this is lesson 4.4, finishing it, and we are, if you hear the word difference, that means subtract. So it asks me to find the difference between x plus 1 over x squared minus 6x minus 16 and x plus 1 over x squared plus 6x plus 8. We do not give two craps about this being x plus 1 and this being x plus 1. That they're the same is just a coincidence. It's not a big deal. It does not matter. When we are adding or subtracting fractions, we must have these denominators being the same. And right now, the form that it's written in, which is standard, I can't tell that. So the first thing I'm going to do is I'm going to rewrite both the fractions. I'm just going to change the way both of them look. I'm going to turn them into factored form. By the way, we cannot multiply one side. We can't multiply something like you can't multiply this by 2 and this by 2. The reason we can't do that trick is because you can only do that when you are in equations where there's a left side and a right side. Then you can. Whatever you multiply this number, you can multiply this side by, and it's fair game. We can't do that in this one because there's no equal sign. This is not an equation. This is an expression. So we're going to have to handle it differently. So we got different tricks to use when it's an expression versus when it's an equation. So right here, this says different signs. This says bigger one's negative. Two numbers that multiply to 16 but subtract to 6. And the 8 goes with the negative sign. Same signs, both positive. Two numbers that multiply to 8 but add to 6. So that's factoring. We shouldn't have to go over that too much. The next step is whenever I am doing adding and subtracting, I have to have common denominators. So I look at this and I go, hey, x plus 2 and x plus 2, they both have that in common. This one has an x minus 8. This one has an x plus 4. So in order to make them have the same denominator, I'm going to say, okay, I'm going to multiply by what does this have that this doesn't? And the answer would be an x plus 4. So I'm going to multiply the bottom by an x plus 4. But whatever I do to the bottom, I got to do to the top. Because really, what am I doing? I'm multiplying this whole fraction by the number 1. And whenever I multiply a fraction by the number 1, it does not change the value of that fraction, just change the way it looks. Same thing down here. I'm going to look at this fraction, and I'm going to say, what do you have that this one is missing? And it is missing the x minus 8. Again, whatever I do to the bottom, I do to the top because I'm multiplying by the number 1. Next, I'm going to distribute the tops. X times x is x squared. X times 1x is 1x. I'm going to hold on to that. 4 times x is a 4x. A 1x and a 4x makes a 5x. And then 1 times 4 is going to be a plus 4. And notice I'm not going to do anything to my denominator. I'm not going to distribute it out. I need to leave it in factored form. And then this one, same thing, distribute it. You're going to end up with x squared. This times this is a negative 8. This times this is a positive 1x. So that gives me a negative 7x. And then minus 8 all over x plus 4, x plus 2, and x minus 8. And really, it doesn't matter the order. As long as I have all the same things. Then these have like denominators. Now here's the trick. This is the new part. Right here, this is really subtracting everything that's back here. So it's kind of like I can, if I had a negative and I had a parenthesis and I had like 3x minus 4, we would distribute that negative. That's exactly what I'm doing here. I'm going to say, wait, I don't want to subtract these fractions. I'm going to distribute this negative sign to all three of these numbers, and when I distribute that negative, that's going to change this to a positive. So what's going to happen is distribute it, this becomes negative. Distribute it, this becomes positive. Distribute it, this becomes positive. So I changed each one of these signs, and then this subtraction became a plus sign. And now this problem should look very familiar because we did this last week. Combine like terms. X and a negative x cancel each other out. 5x plus 7x is going to get me to a 12x. 4 plus 8 is going to be a 12. And then all over x plus 4, x minus 8, x plus 2. And I'm then going to see if I can factor the top, because if I can, maybe something will cancel out in the bottom. Not always guaranteed, but maybe. So I do want to look at that. And when I factor this, that's greatest common factor, factoring out the 12. I get this. And when I look at this, nothing in the top has anything in common with anything in the bottom. So actually, that would be my final answer. Or this could be my final answer. Technically, either of these two things could be your final answer. This would be your final answer with this, and maybe they even distribute this junk out. Maybe they do that. They could do that to you. And I'm talking more like SATs or whatever. You should know how to distribute that. But maybe this is an answer, maybe this is an answer, but either form is kind of acceptable. Does anyone have questions on what I just did for that problem?
At any point, would we have to state restrictions?
Did we cancel anything out in this one, Kelly?
No.
So technically, no. If they ask you to state the restrictions with it, then yes. You should be able to identify the restrictions. We should actually be able to identify that they are asymptotes and not wholes. So like you should know that x can't be -4, can't be 8, and it can't be -2. That's where the restrictions are. But technically nothing canceled out, so I don't have to worry too much about the restrictions. Let's say that instead of this being a x plus 2, it was an x plus 1, and then this cancels out and this cancels out, and then I have that. You do have to state that restriction because you did cancel it out. You for sure have to put that as part of the answer.
Okay, that makes a lot of sense. Thank you.
Yep, but since the restrictions are still there, Kelly, you're honestly, you're kind of assuming you're talking to someone intelligent when you give them this answer. And what I mean by that is they should be able to see that your x isn't allowed to be -4. They should see that your x can't be +8. They should see that your x can't be -2 because they're still in the denominators. But the one you cancel out, they wouldn't be able to see, and that's why you have to include that one if you ever do cancel one out. All right, next type of problem I'm going to show you, and then basically the rest of the class, you are going to have some time to try some on your own. Now, this problem might look scary. In fact, it probably does look scary, and it's cool if it does for right now. But I want you to kind of practice telling your brain to stop, tell it to shut up, and relax. Okay? Don't get scared of these problems. We are going to attack them. We cannot be scared of them. So the biggest thing we're going to do is first, we're going to deal with this top. We're going to see this as kind of two parts, two different problems. My first problem is I need to add these two together. So I'm going to kind of take it to my side paper. This is how I would attack this problem if I was doing it on my homework. I would take that to the side and I'd deal with this. Okay, how do I add these guys? Well, in order to add them, they have to have a common denominator. Now, one common mistake is kids are like, oh, look, these guys look almost like they have a common denominator. I'll just add one here and I'll add one here. And can't do that. You are not allowed to add to the bottom and to the top. That's not what we did. The way we do this is we can multiply the top and bottom by some number, and that's fair, but we cannot add. So what would I need? What's going to be my least common denominator between this and this? Well, my least common denominator is actually going to be x and x plus 1. If I just multiply those, if both of them have an x and an x plus 1, they'll be the like denominator. So I go, okay, what is this one missing? It's missing the x plus 1. Whatever it's missing, I have to multiply top and bottom to it. This one has the x plus 1, so it's only missing the x. So my denominators for both of them, I'm going to rewrite them. I like the x forward, so it's okay for me to write this. I'm going to write it as x x plus 1. I'll write this one as x plus 1. And then I would technically know that this is in parentheses, and I should distribute it, but since it's a 1, 1 times x is just x, 1 times 1 is just 1. If that had been, say, like a 2, then I would have got 2x plus 2 down here. So you got to make sure you distribute that. And then here, 2 times x is just 2x. Now we know how to add fractions. We keep our denominator. We worked really hard for that denominator, so we're going to keep it. So we kept it. And we add the tops. A x plus a 2x is 3x, and then plus 1. So now I have cleaned up this top. Now instead of writing all that garbage, I can write 3x plus 1 over x plus 1 divided by 1y. Does anyone have any questions on what I just did? Adding those fractions together. Okay, next, what I need you to see is this is a big giant fraction. So this right here is really a division problem. And whenever I run into a problem with math, again, I can't change the value of things. I can only change the way they look. So what I can do is I can say, hey, I can write this as a fraction divided by this as a fraction. So like over here, I could write it as this. And then again, this doesn't change the value of it. All I'm doing is just rewriting it a different way. Now, why would I want to write it like that? Because in this form, it's much easier for me to say I don't want to divide, I want to keep, I want to change, and I want to flip. And I end up with 3x plus 1 over x plus 1 times y over 1. It is important to remember that this is in parentheses. And since it's multiplication, I can change the order of that. So I want to write it as y. Sorry. 3x plus 1 over x plus 1. And that would be the final answer. That might be the one I see. Or they might distribute all this stuff, and 3x times y is 3xy. 1 times y is just y. Over, distribute x squared plus x. This might be the answer that you see on your test. This might be the answer. Either of these two could be there, and they would definitely be correct. Questions on that problem? Questions on how I attacked it? Whenever you have two fractions in a fraction like this, the first thing I did, whether it's in the top or bottom, is I took this to the side. Man, this thing is acting up. I took this thing to the side and I combined them so that they were one fraction. Then when I have one fraction, a fraction over another fraction, I write it like this, and then I can keep, change, flip it. So you might not have two fractions in the top tonight for homework. They might be, or the question I ask you in a minute, two fractions might be in the bottom. You do the same process. You would still take these two fractions over to the side and make them one fraction, and then get it so you have a fraction over a fraction, and then you can write it in this form. Questions on that? Questions?